All right, what we're going to be talking about today our linear functions is rate of change. Another word for rate of change that you'll hear is slope. There are four types of slope. So if you go left to right, you'll notice that your slope will go uphill. That's a positive slope. If you're going left to right and it looks like it's going downhill, that's a negative slope. If it doesn't look like your slope is going up or down, it's just going left to right, that's a zero slope. And if your slope only goes up and down, it's an undefined slope. So there's a couple things that, one thing you could draw just to remember is if you haven't watched a video of Slope Dude, we'll make sure we watch Slope Dude. But Slope Dude's talking about going skiing. And you start left to right, so he goes puff, puff, positive. Nice, negative. He says this is zero fun because it's a zero slope. And then he says the worst curse word in all of math is undefined. So this is just a little way to help you remember if you need to know which one's there. Also, another little trick with slope is that you can have a zero in the numerator. That's okay, because that is a function. But the zero cannot be in the denominator because this is undefined because your x's repeat. So undefined means your x's repeat and it's not a function. So I'm just going to write function. Not a function. It's a straight line, but it's not a function. All right, so there's a couple little tricks to remember also when you're doing this. Hooyvuks. So if you were to hear hooyvuks, or what we use this for, is if you were to have a horizontal line, it has a zero slope, and you write the equation as y equals wherever it crosses the y-axis. So if you look over here, all of your y's seem to repeat. If you were to plot each one of these points, remember you go to the left 2 up 3, then you go to the left 1 up 3, and then at 0 you just go up 3. And then here, you go right 1, up 3, right 2, up 3. So when we're plotting our points, if you notice, all of your y's repeat. So if all of your y's repeat, you're going to end up with a horizontal line, and that has a zero slope. And it crossed the y-axis at 3, so that's exactly what you're going to put there. It crosses, and I read it as it crosses the y-axis at 3. So that's how I remember it. Now, you can also have, for vuks, you can have a vertical line, which means it has an undefined slope, and you write the equation as x equals a number. So again, if you're to plot all of your points here, and you're to go -4 down 2, -4 down 1, -4 0, -4 up 1, and then -4 up 2. So if you were to look, all of these create a vertical line. So vertical goes up and down. So that would be an undefined slope. You write your equation as x equals -4, which is where it crosses the x-axis. So, and that's how I read it. It crosses the x-axis at -4. All right, so here's some examples down here. So what I like to look for is this first one. We're going to look at these ordered pairs. If you notice, the 3 repeats. So since it's the x value, you write the equation as x equals 3. And that has an undefined slope since it's x equals. And an undefined slope is vertical. And remember, vertical goes up and down. All right, so now let's look at this next. Here, if you notice, your 9's repeat, which is your y's. And then since it's your y's, it's going to be hoi. So it's a zero slope. And the line is horizontal. So I want you to go ahead. I want you to try these two. And then we're going to talk about rate of change. Rate of change is the change in quantity over the change in time. So whenever we're talking about change, we're talking about the difference or subtracting something. So change just means the difference from one to the next. So let's look here. At 3 weeks old, a corn plant is 4 inches tall, and at 15 weeks is 46 inches tall. So we want to find the rate of change and the height of the plant. So you want to look at quantity over time. So quantity over time, and then quantity over time, and then you're subtracting them. So 46 minus 4 is 42, and then 15 minus 3 is 12. And divide those out, and you will get 3.5 inches per week. So I want you to go ahead and try that. So remember, it's going to be quantity over time, and then you'll subtract those and you'll find your answer. So go ahead, try that one. All right, so now we're going to talk about slope. Slope is very important to understand when we're graphing linear equations. So some of the ways that you've seen slope is m is the variable it represents, and it's your rise over your run. So remember, rise is your vertical, run is your horizontal. That's one way to show slope. Another way to show slope is your slope formula. So it's y2 minus y1 over x2 minus x1. So you're always finding the difference between the two. You also hear it said change in y over change in x. Or you can have delta y, that's what the triangle is, over delta x. And in this case, delta means change. And whenever you see change, you're subtracting. All right, so let's go ahead. Let's look at this first one. Your goal is when you're doing slope from a graph, you want to make a right triangle. So it doesn't matter which point you start at. I started here, and from here you need to make a continuous right triangle. So I'm going to erase this. Make a continuous, oops. Did I spell that right? Continuous right triangle. So what that means is once you start, you don't pick up your pencil and move it to someplace else. So I'm going to go down 2, and then I'm going straight over to 3. So we made a little right triangle here. And so since we started here and we went down, that's a negative. And then since from here to here we're going right, that's a positive. So it's your change of y over your change of x, and your slope is 2/3. All right, now I'm going to go over here, and I'm going to, it doesn't matter which one you start at. I like to go down 1, so that's your numerator, because that's your y. And then now I'm going to go 1, 2, 3, 4 to the left 4. Now when you put those together, it's going to simplify to positive 1/4. Now, if you looked, I could have gone up 1 and then over. I still would have had plus 1 over plus 4, which is the same thing. All right. I want you to try these two. These are tricky ones, but look back at your Hoy and your Vux. That will help you. All right, now we're going to find the slope given 2 points. So there's different ways to do this. It's whichever way you feel comfortable with, but one way is to use the formula. So remember, your formula is your y sub 2 minus y sub 1 over x sub 2 minus x sub 1. All right, now what I like to do is I always like to put the values in parentheses in case you have multiple negatives. So it doesn't matter which one's the y2 and the y1. For me personally, I like to just use the first number for your y to put here, but you could start with negative 6 if you wanted to. We'll still get the same answer. So I'm going to go negative 12, and notice I put that in parentheses. And then so that's my y, so I'm going to subtract my other y, which is negative 6. And again, I put that in parentheses because I'm subtracting both of them. So when you simplify, your two negatives make a positive, so you're going to get -6. Now let's take our x's. So since I started with this one, I have to start with this one. So -7 in parentheses, and then I've got -7 in parentheses, and then I subtract them both. Well, these two change to a positive, so I'm actually going to get 0 in the denominator. So remember, we said no, you can't have 0 in the denominator, so it's undefined. The other way to do it is with a table. So the table, you're just finding the distance between the two and what direction you're moving. So you could start at -12, and to get to -6 on your number line, you would actually go up 6. And then if you're at -7, you wouldn't go left or right because you stay there, so your change is 0. So either way, we're still going to get the same slope. So whatever you feel comfortable with is how you should do it. So I don't care if you do formula or table, just make sure you know how to do both. All right, go ahead, I want you to try those. And now we're going to talk about a constant rate of change is linear and a variable rate of change is nonlinear. So if it's constant, meaning the same, it's linear. All right, so what we got to do is we got to look to get from 5 to 11, you're going to add 6, and then to get from 11 to 20, you're adding 9, and to get from 20 to 23, you're adding 3, and to get from 23 to 29, you're adding 6. Now, right now that looks different, but remember, slope is a fraction, so you're going to have to find the y over your x. So we want to go ahead and do this way too. So remember, you're going to make a fraction of your y over your x, and it simplifies to 3. So for this to be constant, all the other slopes need to simplify to 3. So we've got 9 over 3, because it's y over x, and that also equals 3. So far, so good. They're both 3. Now let's try this one. So we've got 3 over 1, because it's y over x, which equals 3. All right, so far so good. And last but not least, 6 over 2, which equals 3. So since they all have 3 for a slope, it's constant, which is linear. Now variable would be here, you go 3 over 1, which is 3. So they all have to be 3 in order to work. Well, from here to here, it's plus 2. And then this is over 1. So 2 over 1 equals 2. So far, those are not the same. So right at this point, I could automatically say it's variable, which is nonlinear. But I continued the pattern throughout the whole table for you to see. All right, now we're just going to talk about the tables and how you show the rate of change slope. So for this, it's still the same thing. Typically, not always, typically time is going to be your x value, and distance or whatever other thing is going to be a y. So again, we're doing our y over our x. So I already showed you to get from here to here, you do plus 3. So we're going to go plus 3 over 5. So your slope is 3/5 throughout the whole thing. So all that means is since your label was miles, and then minutes is your x, so you're going to drive 3 miles for every 5 minutes. So that's all we're doing is understanding that. And then here, to calculate the slope, you're going to look at the graph and you're going to determine the slope. So I would use these points. So remember, these are your x's. These are your y's. And you're going to set up an ordered pair and you're going to find slope using a formula. All right, I'm going to give you a hint. You will have a negative slope. So that means something's going to decrease for here. So go ahead. I want you to try this one. Set up ordered pairs. All right, when the rate of change is constant, it'll form a straight line when graphed. So the constant rate of change of a line is its slope. Slope measures the steepness of a graph. So if you're to look here, I already plotted these points on the graph for you. And if I were to connect them, we see that first off, it is a positive slope. So that means it's going up, whatever it is. All right, now here is to look at different parts of the graph. So it says, find the rate of change for the following graph, explain it in words. Well, I've got it set up for you, but you're going to finish this. But if you notice, it's student budget per year. So when you're looking at this, if these are your X's, and this is your Y, so we know that your Y is student budget and your X is year. So that's going to help you is it's the per student budget for every year. So find slope, and then I want you to go ahead and determine how much they're gaining or losing per student for their budget each year. So remember, slope is your rise over run. You can use the slope formula. You can do the change in Y over change in X, which is, this is the same thing. I just say change in Y over change of X. And make sure you understand your different types of slope: positive, negative, zero, and undefined or no slope. And then you can remember some of the little shortcuts that I have for you. And that's your quick review of slope.